So let's talk about cache replacement policies. So when a cache is too small to hold all the data of interest at once, we're going to have to replace some data. So when that cache is full, in other words, all of the locations in the cache are valid, a program accesses data X has to evict some other data that's already in the cache. So if it accesses some new data that's not in the cache, it's going to have to evict some data that's in the cache. A capacity miss occurs when we access Y again. So that means that the cache wasn't large enough to hold all the data of interest. So how do we choose Y to minimize the chance of needing it again? The most common method for doing this is called least recently used, or LRU replacement. Basically, we're going to choose the block that was least recently used, so used longest ago. So here's an example of LRU replacement. Let's suppose we have an access to address 4, 24, and 54. So here's address 4, hex 24, and hex 54. And here's 54. And here we have, we're going to use a block size of just one word in our block. And so now we're going to look at this and say, well, let's look at the set bits. We have 4 sets in this case. And so we're going to use 2 bits for the set bits. Remember, these are the byte offset. We'd only use those if we're doing a load byte or a load half. And then we'd look at the next bits are going to, or the remaining bits are going to be the tag bits. And so we can see that these all map to set 1. And so this first access to address 4, we're going to put the data that's in address hex 4 here. And the tag will be all zeros. And we'll make that that valid bit 1. So that's the first access. And then the next access is going to be address hex 24. And we're going to say valid bits 1. We're going to put that, whatever is that address to hex 24 here. And then we're going to make the tag, whatever that tag is, all zeros and a 1 0. So the problem happens when now we have to access the third value, or the third address here, which is hex 54. And so we look at that and we say, well, which one should we evict? So least recently used says, well, the most recently used was hex 24, and so we don't want to evict that because we, temporal locality, we use that most recently. Instead, we'll evict this least recently used one, which was hex 4, evict that from the cache, and overwrite it with, hex 54 tag and the data at hex 54. And so this is written more nicely here, but not real time. So we have, this is the case here when right after this access where we have hex memory, or the data at memory address 4 and address 20 hex 24 there. And this says this use bit, we now add this other bit here of information. It's called a use bit, U equals a use bit. And it says which way was least recently used. Well, way 0 was least recently used. So it says that's the way to replace if there's another access. So in fact, there is one more access here, our access to hex 54. And because that use bit was 0, it says evict what was there. So evict hex memory at whatever that data is at hex memory address 4, and pull in, replace it with that new data with hex 54. So that's LRU, or least recently used replacement.